Today we are going to go over the first derivative with the product and quotient rule. Product and quotient rule are extremely similar, and I will show you a way to help memorize them. So our product rule is when you have two functions that are multiplied together. So we'll have f of x times g of x. And I'll show you some examples a little bit later. When you take the derivative of two functions being multiplied together, it's going to give you d prime of x, which is the derivative of g of x, times f of x plus f prime of x times g of x. This is the same thing as if I did g of x first times f prime of x plus g prime of x times f of x. The reason why these two are the same is because they're both added together. So no matter which way you put them, you're not going to change the sign of any of your function. I always tell my students to use this one first, because for product rule, order doesn't matter. That is not the case for quotient rule. For quotient rule, order does matter, and I'll show you why. So if we take the derivative of a function f of x over a function of g of x, our order is going to matter because g of x always has to come first and be multiplied by the derivative of f of x, so f prime of x. And instead of that addition sign that you use for product rule, this is going to be subtracted. With subtraction, this is going to affect anything that you multiply here or add and subtract here. That negative is going to carry into every single other term here. That is why your order matters. So I recommend you write it this way for both product and quotient rule, with g of x first, not derived, so that you can make sure that your quotient rule you get right. Because g of x goes first, it is also squared on the denominator. So he's a really important guy. He goes first and he's squared on the denominator. Product rule has us where it doesn't matter the order, but I do recommend you write it this way while you're still learning so that you can make sure you write your quotient rule correctly, because order does matter because of that negative. I'm going to next write some different examples of what some product rule problems are going to look like and what some quotient rule problems are going to look like, so you can kind of clarify which ones would be which rule to use. Some product rules examples include x squared plus 4 times x to the fourth. So when it means having two functions of x, it just means that you have two different sections that have an x value within them. So another example would be something like this: sine of x times x squared. That is also a product rule problem. Or it could be something like this, where you have two trig functions being multiplied together. That is also product rule. Product just means multiplication. Some quotient rule examples are when two functions are being divided by each other. So you always have something on the numerator and something else on the denominator that include an x value. So x squared plus 4 over x cubed minus 3. That would be a quotient rule problem because you have a function of x on top, a function of x on bottom. And this cannot be simplified because I can't just divide x squared by x cubed. I should divide x squared by x cubed minus 3, the entire denominator. Another example would be sine of x divided by cosine of x. Or x squared all over x cubed minus 2x plus 3. These are all quotient rule examples. One important comment I have is don't mix your quotient rule up with problems like this below. If you have a problem that has a 1 over x squared minus 3, this is not quotient rule because you don't have a function of x on top. We need a function of x, means x is involved. All we have is a number in the numerator, which means this is just going to be a power rule and chain rule problem, because technically our denominator has an exponent of 1. So if we pull him up to the numerator using our exponent rules, This is the same thing as x squared minus 3 to the negative 1 power, which means you're just going to use the chain rule to find the derivative alongside your power rule, which means this is your extended power rule problem. So please don't mix up anything that has a number on top with quotient rule. It's just a number divided by a function, which means it's just a function problem, a singular function problem. So I'm going to do the first product rule example that we had, which was x squared plus 4 times x to the 4th, to show you how I break this problem up in order to make sure I do the rule correctly. Our product rule tells us that if we're taking the derivative of a function times a function, we need to do g of x times the derivative of the other one plus f of x times g prime of x. So they really just flip places. G of x is not derived on the left, but it will be derived on the right, and vice versa for f of x. F prime is here, f of x is here. So it's derived only on one side, not the other. And as I said, always put g of x first so that you don't mix up your quotient and product rule. Another thing I always tell my students to do is go ahead and break up your problem on the right side of your paper, especially during a test, and write out each of those separate sections so that you make sure that you write it correctly. You're able to just fit them into this rule. So in this case, our f of x is our first function, x squared plus 4. And our g of x is x to the 4th. Well, the derivatives of that, we can just use our power rule, which means x squared. If you bring your exponent to the front, you'll have 2x, and you take 1 away from your exponent. So 2 minus 1 will leave us just with 1. And then the derivative of your plus 4 constant is always 0. So it plus 0, which we don't need to write, so I'm going to go ahead and take that away. So now we have 2x as our f prime of x. G prime of x is the derivative of x to the 4th. Power rule says bring that exponent to the front and then take an x away. So 4 minus 1 will give us 3. Now we have all the sections and the pieces to our product rule. Next, we go ahead and put it into the function here. And to take the derivative of this, we need to put g of x times f prime of x plus f of x times g prime of x. Well, g of x we have right there, x to the 4th. F prime of x is 2x. F of x is x squared plus 4. And finally, g prime of x is 4x cubed. In order to simplify, we just need to multiply n. So 2 times the 1 here that technically exists is just 2. X to the 4th times x, well, they have the same base, meaning we can add their exponents. So it's x to the 4 plus 1. So now we have 5 x's being multiplied together. So x to the 5th. Next, I'm going to go ahead and multiply 4x cubed into these two terms like this. 4x cubed times x squared is going to be 4x to the 5th. 4 times 4x cubed will be plus 16x cubed. So remember, exponents you just add. So 3 plus 2 gives me that 5. And 4 didn't have any x's, so now he has 3. The last part for finding our derivative will be simplification. So 2x to the 5th plus 4x to the 5th. Those are like terms, because they both share an x to the 5th. So we can add them together. We have 2 of them plus 4 more of them. So we will have 6x to the 5th plus 16x cubed. And we're done. A quick comment. This is a polynomial function. Polynomials always have x to the 4th, x squared, x cubed, etc. in their functions. You can also multiply this 4x to the 4th in here from the beginning and use the power rule to simplify. So I'm going to go ahead and multiply it that way so you also see another way that you can solve for polynomials. So we have x squared plus 4 times x to the 4th. And we are going to take the derivative of that function. So if I multiply x to the 4th into both of these I'm going to do x to the fourth times x squared. Well, if I have 4 of them and I have 2 more being multiplied, it's x to the 4 plus 2, so x to the 6th. 4 plus 2 is 6. Plus 4 times x to the 4th, we're just going to have 4x to the 4th. And if I take the derivative of that, power rule tells me that if I have x to an exponent, you bring the exponent to the front and you take 1 away. So bring the exponent to the front and take an exponent away, or take an x away. So for here, if I bring this exponent of 6 to the front, I will have 6x, and then 6 minus 1 would be 5. For the next one, I bring that 4 exponent to the front and multiply it by that constant. 4 times 4 is 16, and 4 minus 1 in that exponent is going to be 3. That is exactly what we got here. So either way that you do it, it will solve and get you the same value. Our second product rule example we're going to do, our function sine x times cosine x. And to quickly go over the derivative rules, the derivative of sine of x is just cosine x, and the derivative of cosine x is negative sine of x. We'll go over trig derivatives in another video particularly, but if you're doing the derivative of any of the trig functions that have a c, they always end up carrying a negative. So that's one way to remember. If it has a c and it's a trig function, you're going to have a negative in your derivative. So our product rule again, which I do recommend you write regularly, is g of x times f prime of x plus f of x times g prime of x. Well, f of x in this case is going to be sine x. And the derivative of sine x is just right above us, so I'll go ahead and write it out, is cosine x. G of x is going to be cosine x. And g prime of x, well, the derivative of cosine, since it's a c trig function, is going to have a negative sine x. So that means our f prime of x, and don't mix this f of x and f prime of x with these two. These two are just used for a notation to keep track of the derivatives of our parts of our product rule. They don't stand for our actual f of x. So if you want to change this to h of x or p of x, whatever you'd like, you can change the variable so you don't mix up your f of x and f prime of x with these two here. Your derivative is g of x, which is cosine of x, times f prime of x, which is also cosine x, plus f of x, which is sine x, times g prime of x, which is negative sine of x. This can be simplified. So anything times itself means that it is squared. So cosine squared x, which is the same thing as cosine x squared, just so you know, can be written both ways. And then since it's sine times negative sine, we'll carry a negative to the front, and that is also going to be sine squared x. That is our derivative of sine x times cosine x, so not too bad. This can be simplified, however. There is a trig identity that says sine squared x plus cosine squared x equals 1. If I want everything to be in terms of cosine, let's say, so leaving cosine here and I want this to be in terms of cosine, I can go ahead and isolate sine here so I can plug in those values for it. So in order to isolate sine, I just need to subtract cosine squared x to the other side. So I'm end up with sine x squared equals 1 minus cosine squared x. I can plug this in place of that sine squared x that I have in my equation. So in order to rewrite our f prime of x, it's going to be cosine squared x minus parentheses, put in this value for sine, so 1 minus cosine squared x, which can simplify when you carry that negative, and we end up with f prime of x equals cosine squared x minus 1 plus cosine squared x. This can go ahead and be simplified. We have 2 of our cosine squared x's, which means we can go ahead and put 2 cosine squared x minus 1. And that is our simplest form for our derivative of our function sine times cosine. Next, I'm going to move into quotient rule examples, and I'm just going to do 2 of those examples that I wrote earlier. So the first example is f of x equals x squared plus 4, all divided by x cubed minus 3. And as I said earlier, quotient rule is just when you have the derivative of a function f of x divided by the function g of x. So a function over a function. And to solve for those, you always do g of x first times the derivative of the f of x minus g prime of x times f of x. This will all be over g of x squared. Not g prime of x, just g of x. So from here we can go ahead and find f of x, f prime of x, and then g of x and g prime of x. F of x in this situation is our top function, so x squared plus 4, and g of x is our bottom function, so x cubed minus 3. Derivative of our top function, x squared plus 4, you bring the exponent to the front for that first term, x squared, and you get 2x to the power of 1, because 2 minus 1 is 1. And the derivative of that 4 there is going to cancel, because the derivative of any constant by itself is 0. The derivative of our g of x function, for x cubed, you bring that 3 to the front, and then you take 1 away, so 3 minus 1 is 2 as our exponent. And that negative 3 is going to go away because it's a constant. Now that we have everybody, we can go ahead and solve for f prime of x. Remember, it's g of x first, so g of x is x cubed minus 3 times f prime of x, which is 2x, minus g prime of x, which is 3x squared, times f of x, which is x squared plus 4. All of this is going to be divided by our g of x function, so x cubed minus 3 squared. Oftentimes you will not have to simplify further than that, so you can just leave the x cubed minus 3 squared on the denominator and don't do anything else with him. And now to simplify, we have f prime of x. Let's first multiply this 2x into both of these terms. So we'll get 2x times x cubed, which is 2x to the 3 plus 1, which is 4. So we have 4 x's now. And then minus 3 times 2x, negative 3 times 2 is 6x. Minus, I recommend always leaving this second term when you multiply them in parentheses, because this negative is going to change everybody's sign in the end. So 3x squared times x squared and times 4. 3x squared times x squared is 3x to the 4th, and 3x squared times the 4 is plus 12x squared. And like I said before, just leave your denominator as it is. Next, I'm going to carry this negative in to everybody. And so that's going to change the sign of every term within there. So when we carry that negative in, we get negative 3x to the 4th minus 12x squared. Carry down your denominator. The next step is to try to simplify anything we can within this numerator here on the top of the fraction. I see that there are x to the 4ths and x to the 4ths, meaning those can simplify or compress, come together. If we have 2 of them and we take 3 away, we'll have negative x to the 4th. We'll have 1 left. Then the x squared for the 12x squared doesn't have anybody else, so he's just going to get carried down. And that negative 6x as well. Carry down the denominator again. You can also see now that we can factor out some values. So everybody is carrying a negative as well as at least one x. So I'm going to carry a negative x out. If I take an x out of x to the 4th, I'll have 3 left. If I take the negative x out of this one, so the negative 12 will become positive 12. And since I have 2 x's, I'll take 1 away. And then taking the negative away from the 6, I'll have 6, and then taking an x away, I won't have any more. This is our most simplistic form, and this is how you would leave it. Sometimes you're able to factor this section right here and cancel something with the denominator, but in this case, we'll go ahead and just end it here. So that's your derivative using the quotient rule. I'm going to do one more example of quotient rule. For my second one, I'm going to do a trig function, sine over cosine. And just like you previously would, or as I said for the quotient rule, I separate my top and bottom into separate little functions. I'm going to separate my top and bottom functions into separate functions. So I'm going to call him f of x, and I'm going to call him g of x. F of x is sine x. The derivative of sine is cosine. Our denominator, or our g of x, is cosine x, and its derivative is negative sine. Since we're coming from a c trig function, so cosine, cosecant, or cotangent, they always cause you to have a negative in your derivative. Now let's go ahead and find f prime of x. And remember, g of x always goes first, and he is not going to be derived. So g of x is cosine x, and then our f prime of x is also cosine of x, minus g prime of x, so negative sine x, times f of x, so sine x. And then don't forget to do your denominator, which is going to be g of x squared. So cosine x squared. Now that we have our function, we can go ahead and simplify it. So cosine times cosine will be cosine squared x. And then here I see there's a double negative being multiplied in. So we'll have a positive sine times sine, which is sine squared x, all over cosine squared x. We have a Pythagorean identity here on the numerator, which is sine squared x plus cosine squared x, which equals 1. Which means this will take the place of our numerator, meaning our numerator is equal to 1. So f prime of x equals 1 over cosine squared x. And that's it. We're done. For longer, more difficult quotient and product rule problems, I will do them individually and post them as separate videos. So this is Calculus with Lauren, and have a good day.